Now the third application is electric field due to a thin charge sheet, okay, at an outside point. Electric field due to a thin charged sheet. Now thin means if you give charge to the one surface, automatically the charge will go to the next surface, okay. If you give the charge on this surface, so the charge is also coming to this surface also. That is called the thin. And that is the difference between thin and thick. Thick means if you give a charge on this surface, it will not go to this surface. But thin means if you give a charge to this surface, it will automatically go to this surface. So therefore, charging on this side as well as in the next side also. So we want to find out electric field here at a point P. So what you have to do if you want to use the Gauss law? First of all, taking this P point, we have to imagine a circular area, suppose ds. See, now what we have to do, taking this ds here as well as the ds here also, the equal distance apart on the either side. So now if these two ds are joined by imaginary cylinder, it will be looking like this. Okay. So the concept is actually this imaginary cylinder. It's actually a horizontal cylinder. It will actually going through this thin sheet. It is penetrating the sheet and going to that side. So therefore, what will happen while it is cutting this thin sheet? It will enclose some charge here as well as in the opposite surface also. So due to this charge, some lines of force will go from this side. And due to the charge on the other surface, some lines of force will go to this side. So therefore, we can actually calculate both the lines of forces, because as I said, thin sheet means charge is here as well as in the next side also. So due to this face charges, we can calculate the lines of force here, and due to the other face charges, we can calculate the lines of force on this particular surface. So therefore, if you apply the Gauss law, again, what we can write, integration of E dot ds will be equal to q net by epsilon 0. So now again this entire integration, as because it is a cylinder, so we can split it into three parts. One is this circle, one is this circle, and another one is this curved part. Okay. So therefore now this circle, let this right surface, let this be the left surface, and this is the curved surface. So you can write it integration E ds cos theta left plus integration E ds cos theta right plus integration of E ds cos theta curve, that is equal to q by epsilon 0, because the net charge is q here, so you can write q by epsilon 0. So therefore now see for the right surface, as because I have said that the surface is a vector quantity and its direction is always perpendicular to the plane. So therefore the ds is this direction, E in the same direction, so theta will be 0 here. Similarly here also ds in the perpendicular, E is also perpendicular, so theta will be 0 here. But for the curved surface, see, if you take a direction, if you take some area ds, so that has a direction perpendicular, so therefore ds and E will be 90 degree to each other. So therefore theta will be 90 degree and cos 90 is 0, therefore this entire thing will be 0. So now for the left surface it will be integration EDS, because cos 0 is 1. For the right surface also it is integration of EDS, and that is equal to q by epsilon 0. So therefore now E is taken out, here also E is taken out. So therefore E into now integration of ds. Now as because this area is ds, so this area also ds. So therefore if you integrate the entire area, so ultimately we will get A, because the entire area of the thin sheet is A. So therefore if you integrate this ds area over the entire surface, ultimately we will get A. On that side also it will be A, so therefore it will be EA, plus on that side also it is EA, and that is equal to q by epsilon 0. So it will be actually 2EA is equal to q by epsilon 0. Now here also you can use sigma, that is the charge per unit area, that sigma can be written as equal to q by A. So q can be written as equal to A into sigma, So if you put this value here in place of Q, you can put sigma into A by epsilon 0. So A cancel out. Therefore, E will be equal to 2 going to the denominator. So it will be sigma by 2 epsilon 0. This is the expression.